Bismillahirrahmanirrahim. This is another video on the magnetic circuit series, and in this we'll straight away go to example 1.4 and the practice problem related to this. So if you want to know the basics, you should see my previous videos. The question is the relative permeability of the core material of the magnetic circuit in figure is assumed to be mu r 70,000 at a flux density of 1 Tesla. So this is the circuit. You can see we have N windings, current I flowing, and this is the core dimension, which is 30 centimeter. We have an air gap, which is 0.50 centimeter, and the area of cross section is given by 9 centimeter square. Number of turn is 500 turns. So with this, we need to determine for this value mu r, that is 70,000, calculate the inductance of the winding. So that is the first part. Then we'll go to second part, which says that in practical devices, the core would be constructed from electrical steel such as M5. This material is highly nonlinear and its relative permeability varies from 72,300 at a flux density of 1.0 to only 2,900 at a flux density of 1.8 Tesla. So for this, we have to calculate the inductance under the assumption that the relative permeability is 72,300, that is in this one, and also we have to calculate the inductance for the second relative permeability, so this one. So this is the question. Now let's proceed. The first part for mu r 70,000. Now this is the equivalent circuit. So this is core reluctance RC, and then the air gap reluctance is RG. So we have to find both. And for finding inductance, we will use this formula, N square divided by R total. So N square, N we know is 500, but R total we have to find from RG and RC. Okay, so to find R total, we need to find RC and RG. And we know this formula, RC is LC divided by mu R mu naught AC. And for the air gap part, we just have G, the length of the gap, mu naught AG. Okay, so we'll for RC we are using this formula, and plugging in the values, we get this answer. One thing you have to be careful here is that the values that we plug in has to be in meters. So like LC here is 30 centimeter, it has to be converted into meter, so it will become 0.3 meters. Similarly, the area of cross section is 9 centimeter square. We have to convert this into meter, so it will become 9 into 10 raised to the power 4 meter. So I hope you can solve this. And the air gap reluctance permeability is 4 pi into 10 raised to the power 7. This is constant all the time. And for mu r, we are plugging in the value given here. So this is the value of RC. And now we'll find the value of RG. So here the gap length, 5 into 10 raised to the power 4. This is 0.05 centimeter. We converted this into meter. So 5 into 10 raised to the power minus 4. Air gap, permeability, area of cross section, and so this is the value of Rg. calculate the total reluctance, add the two. So the total reluctance is approximately 4.46, 10 raised to the power 5 ampere turns per Weber. Now plugging in the values for the formula for inductance, L, N square over R total, 500 square over R total is this value that we got. So inductance is 0.561 Henry. So this is the first part. Now in the second part, we have to calculate the inductance, but in this case now the permeability is 7 to 300 instead of 7 to 1000. So we just follow the procedure that we followed before. So I will not go into the details, exactly same thing, just here we have changed the value, everything else remains same. So we calculate RC, RG, there is no change because of the change in the material. So RG, the previous value that we got, we'll use that RG from the previous slide, and R total and inductance just we did as we did in the previous slide. So this is for this permeability 7 to 300. Now let's go to the last part. Now here we will use the permeability of 2900, and exactly same way, I'll not repeat, just we have changed the permeability here, and so we are getting this value, Rg same, R total, and the inductance is 0.468 Henry. Now the key point to note is that this example illustrates the linearization effect of a dominating air gap. So air gap is the dominant factor here in the magnetic circuit. In spite of reduction of the permeability of the iron core by a factor, so initially we had this, and the second part we had this permeability, that is, it was reduced by a factor of 25. The inductance decreased only by a factor of 0.83. So this was in the case of a second one, and this was the inductance in the first case. So there is very little reduction in the inductance, although the permeability was reduced by factor of 25. So this is because the air gap is the dominant or the significant player in this. Okay, in the practice problem, there is nothing new. They want to calculate the first part that we did in the previous. Only change here is that the relative permeability is 30,000 instead of 70,000 that we had. So we'll just follow the same thing, inductance formula, the formula for the reluctances, calculate the value of the core reluctance. This one is changed, mu r. Air gap no change, so air gaps remain same as in the previous case. Total reluctance will now change slightly, 4.5 into 10 raised to the power 5, and the inductance now can be calculated by putting the values in the formula, which is 0.056 Henry. The answer given in the book is 0.554. We got 0.556. So we are very close. So I hope this gives you an understanding as to how to solve this type of problems. Thank you.